Luna is the moon on Earth. It's also a platform that brings everybody together. It's like a picnic. Everybody contributes. Together we will learn and we will have a mission for the moon. Luna is a very important project for me. We started working on this already 10 years ago. And now when I step into Luna, I open the doors, I see the landscape of the moon, the light of the moon in front of me. It makes me super happy, also proud, because it's so much better than what I dreamt of 10 years ago. So you're stepping into Luna, you see what you will see on the moon. You see rocks that are identical of the composition as on the moon. You see the sand as on the moon. You see a relief and the light conditions as on the moon. And since we will be flying to the South Pole area, the light will be very low on the horizon. And that's what we have here. And you see dark and long shadows. And these shadows are so hard, purely black, so you cannot see anything inside. And walking on the moon will be challenging in the future. And so stepping into Luna in the morning, I see all this and I think, okay, how will it be when humans will walk again on the moon? The sand, or regolith, how we call it, that we have here in the hall, it's identical like the sand on the moon. It's not from the moon, that's for sure, but it has the same physical properties, the same sizes, so it's very dusty, and it has the same chemical composition as the samples that the Apollo astronauts brought back in the 70s from the moon. And it's very interesting behavior of the sand, because when you first start walking on that sand, it's so loose, you sink in almost like up to your ankles. And then when you do a few steps and you walk again on the same area, then it's suddenly really hard. So it solidifies. And that's an interesting behavior that we need to understand, because walking in loose sand, it gives us a wobbly feeling. We might trip and fall on the moon. And this loose sand we will feel like on any slope when we go down a crater. But walking on an even area where it is already solidified, it's much easier. Then you can even drive, as we have seen during the Apollo missions. So the sand that we have here has a powdery fraction. So when we walk on the sand, you will also see that it levitates, and so you have some dust in the air. And this dust, it also gets into your clothes, in the spacesuit. And all the joints that we have, it sticks in there, and it reduces the mobility. And it also reduces the joints, the ceilings. So when we use spacesuits, we want to make sure that the air stays inside, because we need to have the air to breathe, and there are no leaks. But with all the sand, there is a risk that there might be a leak coming. During the Apollo times, they could only use their spacesuits for 3 spacewalks, which means 3 days on the moon. But in the future, we want to be much longer on the moon, at least 7 days, or maybe like twice 7 days, or 14 days, 21 days. So we need to make sure that the spacesuit is well sealed and it doesn't fail if it gets in contact with the dust and the moon sand. Also, in the future, we will have rovers on the moon, and the rovers have rotating parts, moving parts. In the past, we have seen some missions fail due to dust getting into the joints, blocking these joints. So we want to test all this equipment here in Luna, and we think it will fail here. But we're happy if it fails here, because then we are sure that it will not fail later on the moon. Here in Luna, we have the environment as on the moon, so you can test your mission as it will run on the moon. You can test your gear, you can test your procedures, and you can test that you are safe. And all this like for a full mission duration. Here in Luna, we also have a real moonstone. All the rocks behind me, they are realistic stones of the geology that we expect to find on the moon. But we only have one piece that actually made the huge long journey from the moon to Earth. So it traveled in 1972 400,000 kilometers with the astronauts Charlie Duke and John Young, who found it on the moon, brought it back to Houston. And there, this rock was made available to the scientists to study it in a small little piece, which was well studied and now is available for display, was given to ESA. And I had the honor of picking up this rock in Houston and bringing it on a plane ride here to Cologne. And whenever I see this small little rock, I start dreaming of how the future will be when we travel back to where this rock came from and what we will do over there and what we will learn. So in a clear night, look at the moon and you will see different features. You will see white areas, you will see dark areas, and you will see small dots on the moon. These are the impact craters where meteorites hit the surface of the moon. And in all these three different areas, you have different rocks. So when we go there, we need to be able to understand what type of rock do I have in front of me and which rock should I sample and bring back to Earth, because I cannot pack the entire moon and put in my capsule and bring back to planet Earth. So we need to prepare and train this. In here, in Lunar, we have all the typical rocks that we expect to find on the moon. And these rocks come from special areas on planet Earth. So we have volcanic rocks that come from Mount Etna in Italy, because on the moon, the dark areas are volcanic areas. The white areas represent the old moon crust. And this stuff we find here on planet Earth in Norway. So we imported some of these rocks from Norway and put them here in Lunar for us to train. And then in the south of Germany, we have a very nice impact crater, the Ries crater. And there we have special rocks which got impacted and mixed. And so they're very fragile and we call them breccia. And we put them here in Lunar to study because these rocks are actually the most interesting ones for our scientists that we should bring back from the moon. So here in Lunar, we will be wearing special spacesuits. These suits are not rated to fly to the moon because they are not vacuum tight, but we can breathe inside. We breathe in filtered air to avoid that we breathe in the dust, because when we walk there on the surface, dust rises and it's a health hazard also for humans. And also a spacesuit usually is inflated to 0.3 bar. So I will walk like this, like a small Michelin man. And this limits my behavior, my working environment. So I'm a bit stiffer and it's hard work inside. And these constraints we need to consider when we develop our procedures. And the training suits that we have here inside Lunar, they limit exactly this, and they feature the same behavior that the real suits on the moon will show. And last but not least, the material of the suit will interact with the dust. It will suffer and it might get stuck. And we need to practice all this to develop better materials and also better procedures. In a spacesuit, if I trip over and fall, I need to be rescued and I will be a little bit heavier and bulkier. And I have only one colleague that needs to rescue me. So he needs to be able to do the right steps. It's like first aid, but on the moon, and we can practice it here. So Lunar has a lot of technical features. We have here the light as on the moon, we have the sand and dust as on the moon, and we have rocks that we expect to find on the moon. Also inside we have a very deep area where we can drill into, because in the future we want to take samples. Samples where we expect that frozen water will be mingled and mixed with the sand. So we can drill into frozen sand here in Lunar, and nobody else on planet Earth can do this. Then also we can have a mix of virtual reality and real reality, and augmented reality, so we can train different scenarios and can adapt them very quickly. We can test procedures on the surface of the moon in a spacesuit, also in combination with gravity offloading. That will be a special feature where I will be hooked to a device that is running on the ceiling and it will pull me up with around 50 kilograms so that I can walk very easily on top of the moon. And we will have a ramp that goes up in several degrees. So I can test, am I able to do this experiment in 10 degrees of inclination? Can I rescue my colleague in 20 degrees of inclination? Or what are the limits, and where should or shouldn't we go on the moon to be safe? Luna is part of an ecosystem. It's not only the hall, which represents the surface of the moon. We also have the interior part, the lander or our moon station, and this is Flex Hub. Also available to test everything like sleeping, eating, setting up our gear before we step on the surface of the moon. In the long run, astronauts also want to have their own food on the moon. So we have a greenhouse that had been tested in Antarctica in a very harsh environment. And we hope that the technology that we developed there will also one day be ready for being used on the moon. Then we want to use the sand and make something useful out of the moon sand. We want to build bricks, and the bricks later on shall become the foundation of a moon house, a moon station. We want to extract oxygen out of the sand to breathe. We want to extract water out of the soil. Water is important to drink, but it's also hydrogen and oxygen. And hydrogen and oxygen is an energy source, so we can refuel our rockets and fly to Mars or wherever we want. So the moon can become our petrol station for space. Then we also have other assets that we want to test here on the surface of the moon, different scenarios, how to produce energy on the moon. We could use solar energy, but we will fly to the South Pole area, and there the sun is very low on the horizon. So solar is not the best option. Maybe we want to go to a different type of energy source. And here Luna is the best place to practice. Luna is part of an ecosystem that has a lot around. We have Envy Hub, we have Flex Hub, we have Eden, and we have the Material Science Institute with a very new facility to sinter sand into tangible objects like a moon rock. Future moon missions will be very complex, and so a lot can go wrong. And in order to practice everything and make sure that nothing goes wrong in the real mission, we want to have everybody in here in Luna and test everything, not only once, but many, many times, to ensure that we have efficient and safe missions to the moon. Luna is for everybody. Everybody means students can come here, run their master project. We can have startups that have a nice idea how to develop an Earth project or an Earth product and make it adapted for applications on the moon. Or the other way around. Maybe we develop technology for the moon and it can be used on Earth. All these startups might not have the facility to test it somewhere else, so they are welcome here. Then Luna is also open for scientists and for spaceflight experts. Basically for everybody who wants to do something in space, focusing on a mission to the moon. Luna is a unique place, most probably the best place on planet Earth to prepare for a mission to the moon. So we hope that besides ESA and DLR, who are the owners and partner of this facility, we will also have international partners from Europe and also from beyond Europe, like NASA or JAXA, Canada, coming to Cologne, and together with us we prepare missions for the moon. Currently our missions lead us to low Earth orbit. We fly to the International Space Station and do research in zero gravity. The International Space Station flies at 400 kilometers. The moon is a bit farther away. It's 400,000 kilometers from planet Earth. And flying to the moon, first we will fly around it, then we will build a small station that flies around it. It's the Lunar Gateway. And from this station, we will descend to the surface of the moon. And from that point in time, everything that you want to do, you can practice here in Luna. We're here in Cologne at the European Astronaut Center, and it's the only place in Europe where we train astronauts to fly to space. And currently these missions are for the International Space Station, which flies at 400 kilometers altitude around planet Earth. And there we do research in zero gravity, which is very important. We can do and learn stuff that we cannot do on planet Earth. In the future, we will fly further away from planet Earth. The next destination is the moon at 400,000 kilometers distance. And there we will land on the surface of the moon, and we will find different conditions than on the International Space Station. There again is gravity. Not as much gravity as on planet Earth. It's only 1/6 of the gravity that we have here. Imagine I would weigh 60 kilograms here on planet Earth. I'm a little bit heavier. But then I would weigh 10 kilograms on the moon. So on the moon, if I jump on the moon, I would jump 6 times higher than I can jump here on planet Earth. On the moon, we want to do different type of science and experiments compared to the International Space Station. So it will not replace a flight to the International Space Station. We want to explore the geology of the moon. We want to learn how our solar system was created. We want to learn more about the origin of our universe. And we want to look into the past of us humans and on all life on planet Earth. We want to understand, how did this life start on planet Earth? How was it created? And that we can do on the moon. We hope to find traces of water in the deep craters, and this is very old water. And it might contain some organic compounds that were the beginning of life. So the moon is very fascinating to learn a lot about ourselves and about the universe. But the moon will also be a stepping stone to fly to Mars. And a mission to Mars will be very complex, even way more complex than a mission to the moon. When you fly to the moon, you need to bring a lot. You need to bring air to breathe, water to drink, food to eat, fuel to fly to Mars. And maybe you also want to bring fuel and all the other stuff to fly back. And you want to bring experiments and astronauts. So the rocket will most probably be full before you have packed all that stuff. So it's much smarter to fly to Mars and to say, I want to make use of the resources that I find on Mars. I want to use the sand on Mars to build a house, to create air to breathe, water to drink, and energy. And also rocket fuel for the flight back. So this will be a very complex mission with a lot of technology. And all this needs to be tested before you fly to Mars. And you can test it on the moon. If you can manage it on the moon, you are ready to fly to Mars. And before you fly to the moon, you can test it in lunar. And that's why lunar is the best place for our space exploration aims and destinations that we have ahead of us.